Okay, so we're in section 7.4. Should be the third page of the notes if you got them. Multiplying powers with the same base. Just to restate what we learned in the last section, 7.3. 7.3, we learned x to the second times x to the fifth is x to the seventh, because there are two x's being multiplied by 5x's. That's a total of 7x's. That's the way we write it. You add the exponents. Now we had some different things in there that we reviewed from lesson 7.1. For instance, x to the negative 4 times x to the 2. If we add the exponents, it's negative 4 plus 2. It's x to the negative 2, but we don't leave it as x to the negative 2. We write it 1 over x to the positive 2. We move it down. That's what we learned in section 7.1. We don't leave negative exponents. We also had this in the last lesson. X to the negative 3 times x to the positive 3 would be x to the 0, because negative 3 plus 3 is x to the 0. But anything to the 0 power is 1. Just the number 1, not x to the 1. So we did a lot of that on the worksheet. But now something different today. To multiply powers with the same base, we add the exponents. That's the same one. Oh, this is the same sheet. Right? I have 7.3 up. Wrong one. There we go. Get the right point. That was 7.3. This is 7.4. Sorry. Raising a power to a power, we multiply the exponents. So here it says a to the m in parentheses to the n. That's different than this. This was lesson 7.3. This would be a to the m plus n. You would add because they have the same base. A to the m, a to the n. This one, we multiply in this lesson. This is lesson 7.4 to restate. So an example, x to the 2 to the 4th power. What that will be is not x to the 6, it's x to the 8. And you might say, well, why? What's the difference? What this means is we would do x2 4 times. So we could write it out this way. Then we could use the properties we learned in section 7.3. 2 plus 2 plus 2 plus 2 is 8. Okay? So we multiply when they're in parentheses raised to a new power. So we're going to look at this one. Again, I'm going to do this one the long way. This would mean p to the 5 times p to the 5 times p to the 5 times p to the 5. Now, if we use our rules from the last section, 5 plus 5 plus 5 plus 5 is 20. You can get there much faster if you remember the rule. When it is a power raised to a power, you multiply and it becomes p to the 20th. So the next one, a to the what? 18. Again, you could write a3 6 times and add them up, but it's going to be 3 times 6. This one, v to the 8. And if you're saying you should have had breakfast, you could say, wow, I should have had a V8. Okay. Sorry, that was an old commercial back in my day. I like V8s. All right, this one is a little different now. Now we've got to add a few things in. First of all, I want to deal with the parentheses because there are rules in math. The PEMDAS rules. Parentheses need to be dealt with first. So I'm going to deal with this piece first. I'm going to leave the x2. And over here, I'm going to take this one, and I'm going to multiply. 6 multiplied by negative 4 is negative 24. Okay? So the rule of the day is we multiply those exponents. So I've multiplied the exponents first. Now from the last section. 2 subtract 24 is negative 22. I don't multiply these because it's not a power raised to a power. I add them. But we don't leave negative exponents, so I rewrite this one as 1 over x to the positive 22 power because the negative exponent moves it to the bottom. All right, next one, similar thing. Leave the negative 2 alone. Deal with the parentheses first. What does this become? W to the what? 21. Now put them together. Negative 2 plus 21 is W to the 19. Same as 21 minus 2. Done. Okay? Deal with the parentheses. A negative times a negative is a positive. So that becomes r to the positive 10. We still have an R3. Now we add them. Same base, yesterday's rule. R to the 13. All right, next. Another property today. Raising a product to a power. What does a product mean? A product means you multiply. So for example, I have AB in here and it's raised to the n. Remember, the A has a 1 on it, the B has a 1 on it. If it's raised to a power, you have to raise them both to that power. So this A would have to be A to the 1 times n. Now 1 times n is just A to the n. And this B would have to be B to the 1 times n, which is just n. So that one becomes A to the n, A and B to the n. You have to do it to both. So a little more simple here. I'm going to look at this one. If I had x2, y4, and I raise it to the third power. Because it's a power to a power, I have to do both of them. So that x has to become x to the 6. That y has to become y to the 12. I have to take the 3 and multiply it by both of them. It's a little more tricky on this example. Change the page. It's 3x to the 4th. So first of all, I have to take that 3. That 3 is to the first power. 1 times 4 is 4. The x is to the first power. 1 times 4 is also 4. Now I grab a calculator, and I have to take 3 to the 4th power. I'm going to get my calculator going, but I'm not going to use it on this one in case I need it for the next one. I probably will. But if I take 3 to the 4th power in the calculator, that gets me 81. And that's our answer. So, have a calculator ready. To do this one, you have to take 7 to the 3rd power, and then 9 times 3 is 27. Does everybody understand what's happening first to those powers? I multiplied them both by 3. But now I need to get 7 to the 3rd power, so we grab our calculator. If you don't have a calculator, get one up front. Make sure you got one. I get 343. All right, the next one. 2. This 2 is to the first. This z is to the first. 1 times negative 4 becomes negative 4. 1 times negative 4 is negative 4. So they both become 2 to the negative 4, z to the negative 4. Let the calculator do some of the work. 2 to the negative 4 is 1/16. would be to the negative 4 yet. But simply put, it is a z negative 4 on top. I don't want a negative exponent. So I take that, and I move it to the bottom, and it makes it a positive exponent. So it's 1 over 16 z to the 4th. No negative exponents in our answer. Still consistent. All right, the next one. 3 to the negative 2. Because the 3 has a first power on it. And 1 times negative 2 is negative 2. The g has a 4 on it. It becomes negative 8. The h has a 1 on it. 1 times negative 2 is negative 2. It'll make it really easy if you use the calculator to figure out what the 3 to the negative 2 is. And that becomes 1/9. That g to the negative 8. It would be right here. G negative 8, h negative 2. I don't want the negatives. So I move them to the bottom, and then they become positive. All right, the next one. 3 to the 1st. 1 times 4 is 4. The x to the 1st. 4. Y to the 5th. 5 times 4 is 20. Take your calculator. Type in 3 to the 4th. That becomes 81. Now you have x4, y20. Since we have no exponents, we're done. No negative exponents. Sorry, we have no negative exponents. We don't have to move anything. All right, now they get a little more complicated. The b. We work with this one alone first. We multiply, we get 15. Now, I usually work with each single one. So we have 8 to the 2nd, because that's 8 to the 1st. 1 times 2 is 2. A to the 1st, 1 times 2 is also 2. And b to the negative 8. So usually at this point, the first thing I do is I take the calculator and I figure out the regular coefficient, the number that's sitting there, the regular number. 8 to the 2nd is 64. Now, those are like terms. So right away, some students want to move the 8 to the bottom. You got to combine these. 15 minus 8 is positive 7. Now, sorry, I should have done this one first, because we usually go alphabetical. The A is to the 2nd, and then the B is to the 7th. And that's it. No negative exponents. Nothing moves down. Because the negative was taken care of with the 15 subtract 7. All right, the next one. 6 to the 2nd. M to the 2nd. Both of those have a 1. 1 times 2 is still 2. N to the 4. 2 times 2 is 4. Now we do the second one. Times 2 to the 4th. M to the 12th. N to the 4th. Six to the 2nd. If you take your calculator, 6 to the 2nd is 36. Go ahead. 6 to the 2nd. Type it in. 2 to the 4th is 16. I'm going to do this now. Now all of these are being multiplied. So I now have to take 36 and multiply it by 16. 36 times 16 is 576. Now I look at the m's. 2 m's and 12 more m's make 14 m's being multiplied. Look at the n's. 4 and 4 make 8. All right, last one. Look at them separately. Do the parentheses first. 9 to the 2nd, because there's a 1 there. 1 times 2 is still 2. X to the 10th. The other one, 2 times 5 is x to the 10th. Grab your calculator. 9 squared. What's 9 times 9, someone? 81. 10 x's and 10 more x's make 20 x's. Thus endeth the lesson.